Hey everybody, this is Larry. This is day 13 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about today's problem. Populating next right pointers in each node. Okay, you're given a perfect binary tree. That's something to notice. Yeah, I misread this at some point. Where all leaves on the same level and every parent has two child. Okay. Um, okay. Assuming that it is perfect, we should be able to do oh, it's constant extra space. I was going to say you can do something like a binary. Extra space. I was going to say something that you could do something like a breadth first search. My first inclination is depth first search because I do everything with depth first search to be honest. But I don't think that makes sense in this case. I think the invariance, ideally, what you want from a recursive solution is that every subproblem is solvable by itself in a self-contained way. But in this case, you have to kind of manipulate the left and the right together. So I don't think that makes sense. I think what I would do is some kind of breadth first search in theory. But in this case, can I do some sort of level first search in extra space? So let's say we have a pointer at each level, right? Can I construct the rest of the pointers in a straightforward way? Oh, it is a perfect. I forgot that it is a perfect binary tree. So maybe there's some assumptions that we can make there with respect to some kind of traversal. But then I don't know how that could be not linear space. Even though maybe we do some kind of crazy recursive thing. But I would also maybe use this time while I'm thinking about this as a disclaimer that I solve these problems live, and this is me looking at it for the first time. So sometimes it's going to be a little bit slow before I get to the answer. If that's not, feel free to watch this on 2x until I get to that part, or skip ahead or watch other videos if you like. I wouldn't feel that bad about it. I just want to give y'all a reasonable expectation because sometimes people do it this way. And to be honest, this is a little bit of a weak point in my interviewing problem solving, I guess, because the constraint is that we have extra constant space, which is something that doesn't come up that much in competitive programming because you always have a lot of space, at least a lot more than constant. And so for me, I have to think about this a little bit because it is a different problem type. And I would also say that, yeah, these kind of problems and linked list problems are some of my weaker problem types for that reason. But, and there are already linker-y stuff to it. So we want to set next. So we can go one at a time. I don't know. But I'm thinking something like um okay, I think I get it. I think what I would need to do is look at each, do essentially a level first search where you have a point on the previous level and a point on this level, and then the point on the previous level will just kind of be the pointer to the previous nodes, and because you've already done the previous level, then you can just move that to the right while kind of pointing. Okay, I think I get that idea. Implementation may be a little bit tricky, so bear with me. So I will explain this idea after I write the code. I think this is easier to illustrate with code. So, stay toward the end if you like. But the idea is that, actually, let me pull up my paintbrush so that I can visualize this a little bit better. Okay, so say you have something like this, right? So what I want to do is, okay, I have some pointers. Okay, actually, I don't need to draw the circles individually. I could just do this, right? That's a terrible circle. But in any case, so you have something like this. Let's say we already did the first level and now we're on the second level. So this is our previous level pointer, and then we start at our current level pointer. And because the previous level we've already done, so we already have this pointer that goes this way. And so on the top pointer, we're going to go to the left and to the right, or we connect the left to the right, and then just keep on shifting the top pointer from left to right while connecting the bottom pointer next pointer as well. So that's kind of the strategy I'm going to do. Yeah. Let me take a look at that. Okay, and now this is the coding time, so let's figure it out. And I'm getting message, so I have to figure out how to turn that off. Okay, so let's just say previous level pointer, current level pointer. So those are the two things we need. I like to kind of say things out, so my code is not as like, it's not just me typing it in, it's me typing it in the order that my mind thinks. Hopefully that's helpful, because for me, this problem for me is not a solved problem. For some problems, I already know exactly how and what I want to do, so you just see me kind of type it in really quickly, but this is not one of those problems. So previous pointer will be, let's just start at the root. We don't need to do the root because the root dot next is none, right? So this is equal to root dot left. So we start at here, and then now while current level pointer is not none, we look at the previous pointer. So, okay, if current level pointer, I'm trying to think about how to do this precisely, because I think there are two edge cases that I have in my head. So if this dot next, well, it is going to be equal to none. So first of all, in the beginning of every loop, the first pointer is going to be, and I'm missing a while loop, so this may be a little bit awkward, and I'll put it in a second. But the first pointer is going to be the current level pointer is going to be the left pointer, and we want it to point to the right. So we do something like this. Next is equal to previous level pointer dot right. Okay, and then yeah, so now while previous level pointer is not none, we do at least one step of this, and then now we want to get to the invariant at the end of this loop, which is that now, well, first move the current pointer to the next. So current level pointer is equal to current level pointer dot next. And then now we want to move the top pointer, the previous level pointer, to the next. So previous level pointer is equal to previous level pointer dot next. And then now we want the current level pointer to be looking at the new left. So if, no, that's okay. I was going to say, I think we have to make sure that this is not none. So if previous level pointer is not none, current level pointer dot next is equal to previous level pointer dot left. and then current level pointer is equal to current level pointer dot next, because then now we just move the bottom pointer, right? And then now what you know, you probably hear the term loop invariant a lot, and this is what the loop invariant is, right? Is that at the end of each loop, the preconditions is still true, which is that the previous pointer is at any pointer, I guess, and then the next level pointer is on the left of that previous pointer. And in this case, this will always be true. And you know, you could prove to yourself why this is true by stepping through it. But yeah, I think this is good for this one. So now this ends a level. What happens at the next level? Well, at the next level, we have to start at the next level, obviously, and then the current level pointer at next, right? So because we're already at the end of the pointer, so that means that we just have to keep track of one more thing, which is that, okay. So previous level pointer head, maybe. So this is the beginning of that pointer is equal to previous level pointer. And then now at the end of these loops, we want to move them down one. So what that means in code is that previous level pointer is equal to previous level pointer head left, right? And this is always going to be not none by the invariant that this is not none. And then current level pointer is equal to previous level pointer. This is a new level pointer dot left, and this could be none, but that's what the while loop does for us. And that's pretty much it. There's no return statement, right? Because we just manipulate this. Let's see. I don't actually know how to format that to problem one, so let's run this and see if that gives us the right answer. No, we have to return it. What are we supposed to return? Maybe just the root. Okay, let's return the root then. It's not very clear. Okay, cool. So this looks okay, I think. It's let's try another case. Is this okay? Nope, missing a note. And also, let's say no elements and one element. Three elements. Ooh, see, there we go. Oh yeah, if root is none. And I don't know if it's in the test case, but I feel like I've been bitten by something similar recently where I'm just making assumes, and you know what they say about assumptions. Cool. So what is the running time of this algorithm to go over it? So it's linear time because we look at each pointer or each node a constant amount of time. In this case, I think 2 or 3 times if you want to count it exactly. And in terms of space, we only have 3 pointers, I think. You have a pointer here, you have a pointer here, and you have a pointer here. So it's going to be constant space. It's a very tricky problem, especially for me because it's new to me. Let me know what you think. Let me know if you have any questions and how did you solve it. Maybe there's another way to solve it, to be honest. I don't know. Yeah, let me know. Hit the like button, hit the subscribe button, and I will see y'all the next day. Bye-bye.